All right, so today our objective is that you're going to use your knowledge of proportions and your knowledge of constant proportionality. And today we're going to use and determine relationships in a table and use that relationship to find missing data in a table. It's going to be a little bit of what we were doing last week and just kind of a small bit of an extension to what we were talking about. So if you haven't already, these notes are on Schoology. You can go ahead and print them out and fill them in as we go. Or you can get your paper and your pencil ready so you can submit your written notes as we go. All right. So relationships, and we this keeps getting brought up because it's that important. So relationships are proportional if they can be represented by the equation y equals kx, and that's just adding to what we've learned. They're proportional if we have that k, that constant of proportionality. From one y value to divided to the x, they have that constant proportionality that matches throughout the table. So last week when we were talking about this being the same, if it is not the same, it can't be represented by this equation. So we are going to complete the table and use the information to answer questions. This is a little bit more of what we were doing last week. So we know that this total cost is going to be our y, and our coffee cups is going to be x. So we have two full sets of information. So again, they're telling us this is proportional. So what we can go ahead and do is pick either of them to figure out our y over our x. So we know our y over our x here is going to be 825 divided by 3. And because we already know our process of this, we're just going to go ahead and plug it in our calculator because we want to know what our y divided by our x is, and that's going to be 275. And we're going to go ahead and just one more time, we're going to try that with 5 cups. So for 5 cups, it says it's 1375. We're going to divide that by our x, so y over x. Let's check and see if we get that same constant. 1375 divided by 5, again, gives us 275. Because we now know that k, that constant of proportionality, is 275, we can go ahead and fill that in here. And we know that because they're proportional, they can be represented with these missing y values are going to be equal to our k times our x. So what that means is that missing cost is going to be equal to that 275 per cup times however many numbers of cups there are. So this is our relationship for our first table. Y is equal to 275 times the times the number of cups. So 1 times 275 is going to tell me that the total cost of 1 cup is 275. Then we can go ahead and say our 275 times 2 cups is going to leave us with 550. We already figured out 3. We can go ahead and say 4 times 275 per cup. It's going to be $11. And let me turn my pen back on because it turned off for some reason. $11. And we can go ahead, and I don't know why I didn't fill my constant in here. And we're going to say 6 cups times 275 per cup left us with $16.50. All right, now let's go ahead and fill in our houndstooth coffee. So again, we're going to go ahead and say that our cost is going to be our y, our number of cups is going to be our x. So we want to know how much 1 cup of coffee is. So we're going to go ahead and say our y, our 560 for 2 cups divided by our x. So the cost of 2 cups divided by 2 cups, 560 is going to tell us, and not times, 560 divide 2, it's going to leave us with 280 per cup. Because that constant of proportionality is that also that unit rate, so that's going to be our price of 1 cup, and we talked about that last week as well. And let's just go ahead and do 6 cups just to check. So our y, or 1680 for 6 cups, divide 6 cups, it's going to be, yes, that each cup of coffee is 280. So we're going to go ahead and say 280, 280, 280, and 280. All right, so now we can go ahead and say our total cost for 1 cup is 280. We already know that 2 cups is 560. We can go ahead and say 3 cups times 280 a cup. It's going to leave us at 840. We can go ahead and say 4 cups again at 280 a cup is going to leave us with 1120. And then for 5 cups, 5 cups times 280 a cup is going to leave us at $14. Let me go back and put all my dollar signs. All right. So what do we notice about the 2 tables? I want you guys to look at this information and try and answer these questions, and then we'll go through them together. Think about what this information tells us. All right, so by now you've already gone ahead and paused this, right? Here's our chart, and here's our questions. All right, so now let's go ahead and see what they've got for us. It says, what do you notice about the 2 tables? What I would say is, 1, I notice that it is cheaper per cup of Seattle. And you could have said it's more expensive to buy the houndstooth coffee. So what proves that both coffee shops sell their drinks at proportional rates? Well, we had 2 pieces of data, and we did our division for both of these to determine that yes, indeed, that y over x, or our k, our constant of proportionality, you could have wrote constant of proportionality. I'm just going to write k because we know that's what that means, was the same every time we changed our cup. For the 2 pieces of information, we checked it twice. For 2 cups and 6 cups and 3 cups and 5 cups, our constant proportionality is the same as cup increases. The price of a cup of coffee didn't change no matter how much more coffee you brought. So now it says, if you purchase 9 cups of coffee at Houndstooth Coffee, how much more would you spend than if you purchased 9 cups of coffee at Seattle's Worth? All right. So, well, we know, let me look to see who is who, that Seattle's coffee, SC, is $2.75 per cup. So, cost equals $2.75. Not $2.50, $2.75 per cup. That's our relationship or our equation. Y, or our cost, is equal to $2.75 x, which in this case is our cost or our cup number. And then at Houndstooth, our cost is going to be equal to 280 times the cup. So now we're going to go ahead and we're just, for our sake of time, we're going to plug it in our calculator. So we know that, 275 times, we're buying 9 cups both times. It's going to be $24.75. And then we know at Houndstooth, it is $2.80 per cup. And again, we're buying 9 cups. It's going to be $25.20. So these are our 2 prices. But did they ask us how much it cost? No, it asked us how much more. So now our last step is to go ahead and say $25.20 minus the $24.75 it's going to cost us at Seattle's Coffee. So we get that it will be 45 cents more expensive. Did you guys get those 3 right? All right, so let's go ahead and figure out this last one. It says a third coffee shop is opening up in a busy business district. What do you notice about their pricing structure? Well, so $2.90 divided by 1 is $2.90. Now we have to go ahead and check them because they did not tell us this was proportional. So let's say $5.70 per cup, or $5.70 for 2 cups divided by our 2 cups, y over an x. So y and x. The cost for 2 cups divided by 2 cups is going to be $2.80. Was it 85? Yeah, that's what I thought. $2.85. Now, for 3 cups, we have $8.40 divided by 3 cups. Now it's $2.80. And then $11 for 4 cups is $2.75. For 5 cups, it is $13.50 for 5 cups. What was that? $2.70. Now, if I had to take a guess, I bet this next one is $2.65. $15.90 divided by 6. And I forgot my decimal, but it should indeed be $2.65. Started with 2 behind the decimal, and we have to end with 2 behind the decimal. All right, so I want you to go ahead and pause this and think about D&E and fill that out. And then we'll talk about it. All right, so by now you've thought about this. It says a third coffee shop is opening up in a busy district. What do you notice about their pricing structure? Does our constant proportionality stay the same? No. We notice the cost per cup decreases. It does, doesn't it? It gets smaller by 5 cents. Each time you buy an extra cup, each extra. So the benefit of this structure is after buying, let's look. I have $2.75 per cup and $2.80. So it might not be good if you're buying this much coffee, but after you hit 5 cups, it's cheaper per cup. So at or after 5 or more cups, it is cheaper. I don't know, unless their coffee is really good at 1 cup, $2.90, I'd probably go to $2.80 or $2.75. But after 5 cups, you're saving money per cup of coffee. All right, so now I want you to go ahead and determine your constant of proportionality. Go ahead and pause this. So I want you to divide all of your y's by your k. Actually, well, no, let me do one first. So we're going to go ahead and figure out our y divided by k. So that means we're determining, it says if the relationship does, use your understanding of the constant proportionality to determine k. The relationship doesn't have one, label it non-proportional. So what that's telling us is we have to check all four pieces. So we know our constant, and I wish they had given us part for this. Our k is y over x. So let's go ahead and divide those out. We have 6.8 divided by 2 is 3.4. We have 17 divided by 5, again, 3.4. We have 27.2 divided by 8 is 3.4. And we have 37.4 divided by 11, again, 3.4. So we have the same constant of proportionality. Is this a proportion? Yes, it's proportional because we have the same constant of proportionality. Proportional. And we know it's proportional because they all have a constant of proportionality of 3.4. All right, so now I want you to go ahead and pause it. And you can use your calculator. Divide out all your y over your k's, or your y over your x to find your k's for this one and this one. All right, so by now you should have already gone and done it. Let's do it together. We have 3 divide 1 is 3. Well, duh. We have 9 over 4 is 2.25. If you finish this out, awesome. Because these are already different, I'm just going to go ahead and say that this is not proportional. My k changed. And if I had to bet, it'd probably keep changing. All right, let's go ahead and check our last one. Our y over our x. Should put that here. Y over x and y over x. All right, so let's try one more time. 18 divided by 3 gives us 6. 30 divided by 5 gives us 6. 42 divided by 7 gives us 6. 54 divided by 9 gives us 6. Is this proportional? Yes. What is our constant? 6. Our constant of proportionality is 6. It stayed the same, so it's proportional. This one changed, so it's not proportional, and there's no constant proportionality because there's no consistency. All right, so a fraction can also represent that constant proportionality in a proportional relationship. So our k, and they're telling us this is proportional, would be our y divided by our x. And 1/3 divided by 1 is 1/3. So k equals 1/3. Because we said y over x. Here's our example. Let me start that over. Here's our example. Y divided by x equal y over x. K equals y over x, which is 1/3 over 1 equals k. So k equals 1/3. And we could go ahead and check this. 2/3 divided by 2. We know with fractions, I'm going to go ahead and do this just because I want us to think about this. Dividing fractions, we know we have to keep, change, flip. You don't remember this, write that down. Keep that first fraction the same. Switch division to multiplication and flip that second fraction. We know that this is going to be 2 over 6 which simplifies to our 1/3. And I could finish that out, but we're going to get 1/3 for all of them. All right, so now we're going to go ahead and do that one more time. Each table shows a proportional relationship. Fill in the missing values. So this is more what we did last week. We are going to, they tell us this is proportional. We're not checking them. We're going to find our k, which is y over x. And we have 1 here. So we're going to go ahead and say, well, what is k? We're going to say y divide x is 6. So here, our relationship, and we're going to go ahead and put our equation. We know that y is always equal to k times x, right? Right. I want you to have that in your notes, but we're going to put above this chart. So y equals k times x. But in this case, k is 6. So for this chart, we have y equals 6 times x. So for this one, we know this is, so for 1, we know y is equal to 6 times 1. So this is 6. And I'm going to go ahead and I'm going to do this. New. Well, I want the whole thing because I'm going to make my chart bigger. Copy. Do something. All right. Yeah, but I want to be able to see it all. All right. So we know that our y is equal to 6x. So here, y is equal to 1. Well, yeah, k is 6. Y is equal to k times 1. So y is 6. And if we didn't already, we're going to go ahead and put our y here and our x here. All right. So then again, for this one, our 24 is our y this time. This time we have y. Y is equal to 6 times, or k, yeah. K times x, which in this case we have 6. Y is equal to 6 times x. So 24 is equal to 6 times x. We can go ahead and divide both sides by 6. So our x is 4. Do we see where this is going? So how about 42 is equal to 6 times x? So we're going to divide both sides by 6. We could write it down. Y is equal, so 24 is our y, 42 is equal to 6 times x. Divide both sides by 6, 7. And this time we're going backwards. Y is equal to 6 times 10. 6 times 10 is 60. And we already said our k, our constant proportionality, is 6. All right, I'm going to do one more with you. I'm going to have you pause this and do it yourself. Where did it go? All right. Yeah. So I'm going to make this one neater because I feel like I shared with you. I flustered a little bit trying to work with this. All right. So here's our chart. So we know that our relationship is going to be k is equal to y over x. So y and x. So 15 over 6 is 2.5. So k is 2.5, and you could have left that as 15 over 6 equals 5 over 2. But I like decimals because we're going to use a calculator. So if you want to keep it as decimals, you can, but you also have to be able to recognize that that constant can also be a fraction. So our constant of proportionality is 2.5 or 5 halves, because k is equal to y over 6. So we've got our k, our constant of proportionality. So this is how our table is going to move. So we know that our y is going to be equal to 2.5 times x. So let's go ahead and say here, leave our x and our y. We're going to go to the top last. Here, we're going to go ahead and put our y equals 2.5x. We know we get rid of multiplication with division. So this cancels. And we have 60 divided by 2.5 means that this x is 24. So we'll plug 24 in for x. Same thing here. 75 is our y, is equal to our constant of proportionality times x. And then we're going to go ahead and divide both sides by our constant of proportionality. Cancel. And our x value, so 75 divide 2.5 is going to give us that our x is 30. And then I filled this in because I wanted to see, I can kind of already see a pattern. You might not. But I have 6, 18, 24, and 30. I know that these are all multiples of 6. So I'm going to put 12 here. So now we know y is equal to 6. Sorry. Y is equal to k, which is 2.5 times 12. And 12 times 2.5 is going to give me a y of 30. And go the opposite direction. All right, so I want you to go ahead and pause this. Work out these two. Remember, k is equal to y over x, y, x, y, x. Go ahead and find that constant of proportionality, and once you have it, your y is equal to k times x. Plug in your k, and then if you have a y value, plug it in for y. You have an x value, plug it in for x to find that missing information. Did you do it? Perfect. Because if you didn't, we're going to go ahead and get started on that. So, x and y. Copy. Let's go ahead and do a new one, just so we have room to work. You probably have room with your pencil, but when I'm working on this computer, it's easy to write it out. All right. So we know k is equal to y divided by x. We had two values here we could have used. So let's go ahead and say that, did I just copy the one we already did? I didn't. So we're going to go ahead and say that k is equal to y over x. So we're going to go ahead and say 12 over 15. And again, you could have made this a fraction, but then you have to multiply and divide by fraction. So 12 divided by 15, you could have said that it was 4 over 5. Or you could have said 4 divided 5 makes our constant, our k, is that 0.8? Yep, 8/10. So our k is 8/10. That's what we're going to put at the bottom. You could have used this, could have used this. But we're going to go ahead and use that, our formula, y equals 8/10 times x to find our missing information. So here we have y being 4. 4 equals 0.8 times x. We'd go ahead and divide both sides by 0.8. And we're going to say 4 divide 0.8 is going to give us 5. All right. 5, 15. Oh, that's why. It's like I did it in the wrong spot. Whoopsies. We did that for 4. So 5. Let's go ahead and try it for 8. So 8 is our y value. So 8y equals 0.8 times x. So 8 equals, we're going to divide by 0.8 again. So now we have, what did I say? Okay, so we have 8 divided by 0.8, and we know 8 divided by 8 is 1. So, yep, it's going to be 10. And I know that I can do all this in my head, but I want you guys to practice with a calculator so you know how to find these. All right, so 5, 10, 15. If I had to guess, these count by 5s. All right, so 20. Now we can go ahead and figure out our last one, but this time we're going to plug in our x. So y equals that constant of proportionality times 20. And that is going to give us 2 times 8 is 16 with our 0. We started with a 1 behind the decimal, so we're going to end with 1 behind the decimal. So 16. Did you get that right? Awesome. Right, let's go ahead and, oops, that was it. Find our last one. So, again, we're going to find our first step is to find our constant of proportionality. And then we're going to use it in our relationship equation, which is always y equals k times x. So we know our constant is equal to y divide x. So this time here is the one we have. So 84 divided by 28. And we're just going to make it a decimal. 84 divided 28 is 3. Our constant of proportionality is 3. So k equals 3, which means y equals k times x. Perfect. And we're going to erase this. Now we're going to go ahead. We have an x value of 7. So y equals 3 times 7 is 21. This time we have a y. So 42 for our y value equals our constant times x. Divide both sides by 3. I know this in my head, but if you don't, 42 divide 3 is 14, because 3 goes into 4 once, and then 3 goes into 12 4 times. All right, so same thing here. We have a y time of 63. So y equals our constant times x. So again, we're going to divide our y value by 3. 3 goes in 6 twice. 3 goes into 3 once. By 3, divide 3, and our x is 21. All right, and then our last one, this time we have an x value. So y is equal to, again, our constant times our x, which is 35. And we're going to say 35 times 3 is 105. Awesome. So let's go back to our learning objective. So in our part that says summarize today's lesson, think about our objective. How do you find that constant of proportionality? How do you use it to find missing data in a table? How do you turn a fraction constant of proportionality into a decimal? You can keep it a fraction, but I know a lot of you would prefer to do it as a decimal. How do you determine whether or not that set of data is proportional? This is kind of just about the same thing we did on Thursday and Friday when we figured out how to find our constant of proportionality. All right. So fill in that summary and make sure you submit those notes. If you are still struggling, please come to our guided practice. Please, please, please. If you feel like you got it, go ahead and get started on the Schoology assignment on this. Have a great day, guys. I'll see you later.